As we begin doing more and more labs in our lab notebooks, and as I ask you to do some more formal write-ups with that, and trust me, they're coming, we're going to have to use a specific protocol when we're writing our conclusions. And hopefully you're a little bit familiar with it from last year, and if you've never heard of it before, it's claim, evidence, reasoning, and we're going to refer to that as CER because saying claim, evidence, reasoning over and over and over again gets really annoying. So, the basic idea behind this CER protocol is writing and defending answers. Most of the labs that we do will have a definite question. The labs that we're doing right now go along the lines of what is the relationship between these two things. Sometimes it'll be more complicated. Other times I'll give you a claim, evidence, reasoning on a quiz, ask you a question, give you some data, and you'll have to do some calculations and things, and then make your claim, state your evidence, and give your reasoning. So, what we're going to do is look at our dropped height versus rebound height example, and we'll do a really quick claim, evidence, reasoning on that. So I'm going to put all the data down that we had in the video example on the first video, as well as the graph. So for this, you would obviously, depending on how I ask you this question, if it's part of the graph, you'd have all this and you'd have all of your work, which is good. If this was on a quiz, I may just give you the chart and then have you graph it and find the slope of your best fit line, and then make your claim, your evidence, and your reasoning. So, it just kind of depends on the setting in which you get a question, on how much extra work you're going to have to do. Now, oh wow, that's taking forever. Let's get that scale going, sorry. So we have our data, we have our best fit line. Here's the question. Given this data, and sometimes you'll get a brief description of what's going on, given the data table and the graph, what is the relationship between dropped height and rebound height? And when we do this, when we answer this, we're going to make a claim. That's our very first thing, is to make a claim. Now this is the simplest part. The claim is just answering the question. What's the relationship? Give me an answer to that question. Tell me what the relationship is. Now as we do this, we do need to write incomplete sentences. But I think we're all old enough to get beyond the relationship between dropped height and rebound height is. We could just say, oh no, we're not older than that. The rebound height is 79% of the dropped height. Any way you want to say that is fine. The slope of our line was 0.79. So what that's telling us is that the rebound height is 0.79 times the dropped height. We get that from the little equation that we came up with. That's all we have to do when it's the claim. It's answer the question in a complete sentence. Give me the answer to the question. That's it. Very, very simple. If you do that, you get full credit for it. The next part is the evidence. With the evidence, I want to know what specific pieces of the given data did you use to make that claim. I need you to cite specifically what it is. So not saying just the data table, but also saying 0.9, 0.68. All of that needs to be specifically cited. So this may take a lot of space to use. That's okay, but you do need to state all of the evidence that you use. If you state wrong evidence, it's going to count against you. And if you don't state enough evidence, it's going to count against you. So you need the pieces that you used. You don't need to tell me how you used it, just what you used. So we're going to say plotting the data points, then we're going to list those points, 0.9, 0.68, 0.6, 0.46, 0.3, 0.023. We got a line with the slope of 0.79. That's my evidence. Now, that's pretty brief, but we didn't need a whole lot of evidence in this. There wasn't a lot there. Then we come to the reasoning part. The reasoning is, how did you know your evidence said what your claim was? We're going to link our evidence and our claim together. But usually we're going to have to bring in some outside information, something that you know from class, something that you got outside of the lab somehow. So in this case, we wrote an equation, and that equation tells us how things work. So using the slope, we can write out that the rebound height equals 0.79 drop height. So then our graph tells us that 79%, the rebound height is 79% of the drop height. It seems a little bit repetitive, but we are linking the evidence to the claim. That's what we're after. The slope is 0.79. That's a piece of evidence, saying that the slope describes the relationship between those two things and explaining how. That's the reasoning. So you'll have some practice with this. We will do this a lot. This is how we are going to write in science. So in your lab notebooks where it says conclusion, most of the time your conclusion is going to be this. You're going to make a claim that answers the question of the lab. You're going to cite the evidence from the lab that gave you that claim. And that may mean writing some things down again. Okay, we're going to write them down again. And then we're going to give the reasoning. That's the thinking piece. That's where you tell me all the things that you know that led you to make that claim.